Hey there, welcome back to my YouTube channel. In this video, we will be building our XG model in Python using Jupyter Notebook. But before we get started with all of that, let's just talk about what we did in the last video. So in the last video, we created our table XG model in MySQL. And we saved it as a CSV file. So this table has all the information that we're going to need in order to build our XG model. So let's just start off by seeing what's in this table. So we saved it as a CSV file, so we can just open the CSV file. So it's right here, XG model. So as you can see, it's a pretty simple table. Just we have the different variables that we're going to use to create our model. So we have shot distance, shot angle, string state. Even strength 1 means it's 5 on 5. Even strength 2 would be 4 on 4 or 3 on 3. Then you have short-handed. PP1 is 5 on 4. PP2 is 5 on 3 or 4 on 3. Then you have the score state. You have the last event. If there was no last event within 3 seconds, then it says no. Otherwise, it says shot if the previous event was a shot, or otherwise it says other. Then you have the shot type. And finally, you have the goal column. So this is like our result column. So what we're going to do is we're going to build a model that tries to predict whether or not a shot is a goal based on these variables. And then we'll use the goal column as our reference, so to speak. But this is what the data looks like. So the next step is to install Python, and then we'll do the model there. But I don't want to go through the installation process. So instead, I'll just leave a link here where Alex the analyst installs Python, installs Anaconda and Jupyter Notebooks, and you can do the same thing. I'll leave the link in the description. Just one thing, on the Anaconda website, it looks a little bit different now. So you have to go to free download, and then you can just skip the registration. And now you have the installations down here. So it's just, it looks a little bit different. Okay, so that's what we need to do. So we have our CSV file that we want to load into Jupyter Notebook, and then we want to run our code. So I've already written all the code. So we'll just walk through it step by step. But the first thing we need to do is we need to open it. So we'll just open Jupyter Notebook. And this is it. So you can see there are a few different projects, but the one that we're opening here is the XG model YouTube. So as I said, I already written all the code, so we'll just go through it step by step. So this is what Jupyter Notebook looks like, and we'll just go through it. So the first thing you always have to do when you're working in Python is to import the libraries that you're going to use. So in this case, we're importing pandas because we're working with data frames. You almost always import pandas as PD. Then from Scikit learn, we're going to import the train test split. So we're using this to split the data into a test set and a training set. Then we're importing the logistic regression model, which is what we'll be using to fit our data. And we're doing that from scikit-learn. And finally, we'll import the AUC score, which is area under the curve, we'll do that just to do a little bit of basic testing. And we'll also import the log loss to do log loss tests. And finally, we'll import numpy as np. So those are our libraries that we're going to import. So in order to run the code, you can just hit Shift Enter, or you can hit the play button. So let's just hit Shift Enter. And now the libraries are imported. So the first thing we need to do now is we need to import our, or we need to load our XG model table here. So we can do that just by copying the path. So now I copied the path and we'll just input that here. And you can see when we say, so we'll just paste it like that. And it's exactly the same because the code was already correct. Now, when you do read a CSV file, you do have to put a R in front of it. I don't know exactly why, but I forgot why you have to do that, but it doesn't work unless there's an R here. But otherwise, we'll just read the CSV, and then because we say, and we'll call the data frame df for data frame, now we'll just try and load what's in the data frame as well. So this is what the data looks like. So this is the exact same data as we had in our CSV file. So there's no difference there. Okay, so far so good. You can see here that there are 121,000 shots in our data. So the next thing we need to do is we need to split the data into a Y data frame, which will be our result data frame. That will just be the goal column. So that's what we're using as our reference when we're fitting the model. So we'll just create that, say Y equals data frame, the goal column, and then we'll just print the Y. And you can see it's just the last column here. And nothing else to say about that. But then we have the X table or the X data frame. And we're going to have to split that into two different X data frames, because we have the first two columns here, the shot distance and the shot angle. Those are numeric variables. So they are already the way they should be. So we just need to know how much we're going to value each feet in the shot distance and each degree in the shot angle. So these are numeric variables. Now the other four columns here, those are what we would call categorical variables. So we can't just input even strength 1 times something times a coefficient. That won't work. So what we do need to do is we need to create dummy columns, but we'll get to that. So the first thing we need to do is we need to just split it up in these two columns will be x2 and these four columns will be x1. So if we go down here, we can see x1 will be string state, score state, last event, shot type. So this is what our data frame will look like. Try and do that. And again, you can see 121,000 rows. And then x2 will be the other two columns, the shot distance and the shot angle. So far, so good. But we do have to create dummy columns for our categorical variables. So you do that this way. I don't want to go through the code because I'm not an expert in Python, but this will work. So this will create additional columns where you have one column for each of the different types of, for instance, string states. So let's just try and run it and we can walk through it. So you can see here that for each shot you have now 5 different string state columns, one for each string state type. And if it's the correct type, so in this case, this shot here is at even strength 1, then it says a 1, otherwise it's zeros. So now we can multiply this with a coefficient so that we know how much to value an even strength 1 shot compared to an even strength 2 shot. So if we go to the end, you can see there are different types of shot here. So the first shot is a wrist shot, then it's a tip in, then it's a snapshot, and wrist shot, and so on. So that's all we've done so far. So the last thing we need to do, so now we've created dummy columns for our categorical variables, and we have our numeric variables, so now we need to just join them together. So we'll join x2 with x1, and this way we create our x table or x data frame. So let's just try and run that. And now we just put it all together in one data frame. So far so good. So the next thing we need to do is we need to split our data into a test set and a training set. So to do that, we'll use the function train test split. And we'll set the test size to 30%. So this means that 30% of the data will be used for testing and 70% will be used for training the model. This way we can do out of sample testing afterwards. So let's just split it up, and it takes no more than a few milliseconds. And then the next step is to do the actual logistic regression modeling. So now we are fitting the data based on the training data, and we're using the logistic regression model to do so. And we don't want to have an intercept in this case, so we'll just put it up like this. And again, it takes just a few seconds to run. And now our XG model is actually has already been built now. So the next step is to try and put the data in 2 different columns. So we'll have one column with the predictions, so one column with our XG values, and we'll have one column with just the goals column, so that we can compare what is the XG versus the goal. So we'll use those two to test our data. So we'll just we'll do that first. We'll create a column called prop, and we'll use the predict proba, which is the predicted value based on the model, and we'll just use the testing data. So we're going to build this based only on the testing data. So we'll just run this. So we have the predicted values, and then we have the goal column. And then we'll do the same with the training data. Usually you would only test on the testing data, but we'll just do the training data as well, just to see if there's any difference. So we'll just run this one as well. And then we'll create a test data frame with just the testing data. So first we'll just create an empty data frame, and then we'll put in the prop column, which will be the data frame that we created up here. or the list that we created up here, and then we'll do the goal column, which will be the Y test that we created up here. So let's just try and run this. And you can see that there are only 36,000 rows now, because there are only 36,000 shots in the testing data, because we only have the 30%. So we could do the same for the training data, just so that we can compare the two. And you can see here that there are 85,000 shots in the training data. Okay, so far so good. So now we can do the area under the curve test. So we'll just use this function here and do it on the testing. Do it on the testing data set. So if we do that, we see that the area under the curve is 0.759, which, if you don't know anything about it, doesn't say a whole lot, but that's actually quite okay for a XG model. I think that's comparable to what other models show. And then we can do the same just for the training data, just to test it out, and you can see it's very similar. Actually a little bit worse, but all in all similar. Yeah, and we can do the same with the log loss, just to test the data. Again, we can use the log loss function here, and we'll set the and we'll use the testing data, and let's see what it says. And it says 0.2194. Again, not perfect for a XG model, but this is a very, very simple model, just with a few variables, but it's still not too bad, actually. We can test the training data as well, just to see how it goes. And you can see the training data is a little bit better, which is not surprising at all, because the training data is because it is part of the model, whereas this is out of sample. So this is what you would expect. Anyway, this is our data model. So now we created the model. So how can we use this? So first of all, you could just take all the data instead of taking just the testing data or the training data. You could take all of the data, and then you could just take this as your XG model. But what's better is to get all the coefficients, and then we can use that to recreate the XG values in MySQL. So what we'll do is we'll create just a table with all of the variables and how much value to put on each variable. So let's just try and run this. So that's what this does. It takes the column names from the training data. So this is only to get the column names, not that it has anything to do with the training data or the testing data, for that sake. And then we'll transpose it, and then we'll take the coefficients from the logrec function. So that's what we're doing here. And then we'll just give the columns names, features, and coefficient. So let's try and run this. And you can see here that short distance has a negative coef, which makes sense. The further you are from the net, the less of a goal probability do you see. So the further you are from the net, the lower the XG value. The same goes with the shot angle. The further you the bigger the angle, the worse the xg value. Again, even strength 1 is more negative than even strength 2. So a shot at 4 on 4 or 3 on 3 has a higher probability of going in than a shot at 5 on 5. Again, makes perfect sense. I think it's interesting to see that a short-handed shot also has a pretty high chance of going in, actually higher than a normal power play shot. So this is likely because many shots short-handed are actually breakaways or 2-on-1s. Anyway, we don't want to go through all the coefficients here, but we'll just say that it worked, and then we'll save it as a CSV file. So we'll say coef to CSV, and then we'll just save it and run the code. So now it's saved it as a CSV file, and it saves it in a user administrator. So that's where all of my Python files are being saved, including the Python file itself here. So we got it here. So here's the xg coef, and it's a CSV file. So we can just try and open it up. Yeah, and that's it. So there are a few problems here. So first of all, I don't know how to get this as a number and not as a text in between the two brackets. So we'll just fix it in Excel. It's quite easy to do anyway. So we'll just say, we'll use the mid function. So it takes the middle part of a text from this one, and we'll start at position number 2 because we don't want the first position. And then we'll say we want to take as many as all of them. So we'll take the length of the entire part of the entire text. But we don't want the first one and we don't want the last one. So we'll say -2. I hope this makes sense. But it just removes the brackets in the end and in the beginning. So we'll just copy this, put it all the way down here, and then we can copy it as values and say delete, and now it's saved it as a text and not, oh yeah, I forgot to use this is a text, we need to convert it into a number. I forgot to do that in the formula. Anyway, it works now. So now it's a number. And this is it. So now we have a CSV file, a table here with all of the values for each variable. However, when we're doing the transformations in MySQL, it's actually better to have it as just a whole lot of columns and then just one row with all the values here. So let's just try and set it up a little bit different. So we'll just insert a few rows here, and then we'll put it all down here, and then we'll just transpose this. So now it's put in the other direction, and we'll do the same for the variables. And we'll go up here and transpose it. And then we'll just delete all of this. Okay, so now we have a CSV file with the type of variable in the first row, which will actually be the column header. And we have the actual value in the only row that it has. So I think this is the easiest way to do it maybe it's not, but this is how I did it anyway. So we'll just save this as a CSV file, and then we'll load it into our MySQL database. But I already did that, so we don't want to do that actually. So what we can do is we can just try and open this one. It might be very, very slightly different because it is based on a different model calculation, but it's the exact same variables, so it should be very, very similar anyway. So but we'll just try and say select everything from xgcoef just to see what it looks like. So this is what it looks like, and you can see, let's just try and reopen it. So you can see the value should be very, very similar. So they're not quite the same. Maybe because the sample size isn't that large. So when you're doing different test sets and training sets, the model will differ just a little bit. Anyway, they are quite similar, and so we'll just use this one. I don't think it's worse or better than the other one anyway. But this is what the data looks like. So I already created the script here that we're going to use. I will just walk through it really quickly, and then that will be it for this video. So how can we recreate our model in MySQL? So that's kind of what we're trying to do here. So what we did was we combined the XG model that we had. So we had the XG model here, and then we joined it with the coefficients. So for each and every, so we can try and just write that out. So we'll just say select everything from XG model as X on event ID. Yeah, so let's just try and run this. So now it takes everything from our XG model, which was the table that we used here, and it combines with the coefficients if event ID is larger than 0, but all of the event IDs are larger than 0. So it's just a way to say that we are adding all of the coefficients to all of the rows. So let's just try and run this. So basically you just have the XG model in the beginning, and then you add all of the different coefficients to all of the rows. So these are just the same all the way down here. So once we have all of the values that we need, then we can create how much value to put on the shot distance. So it's just shot distance times the value for each feet, so to speak, and then shot angle is times the shot angle. But then it's a little bit more difficult with the categorical variable. So here you have to say if string state is equal to 1, then it's this one. If it's equal to 2, then it's this one. If it's equal to pp1, then it's this one. So I just wrote a case function that says if string state equals this, then we'll take the value in this column. If it's even strength 2, then take the value in this column, and so on and so on and so on. Then we did the same for the score state. Now, just one comment to the score state. So you have to put these backticks on when you have score state underscore -1. Because if you don't have that, it can't read it as a column name. Then it reads it as score state as the column name, and then just -1 as a number. So you have to put in the backticks. And those can be a little bit difficult to find on your keyboard. But they are there, I promise you. So other than that, it's the same. So score state, you put in the correct score state. So in this case, the score state is 0. So it has to have the value score state 0. So this value. And then finally, you do the same with the last event and the shot types. And again, here when you have shot type wrap, and this one, you have to put in these back ticks again. But other than that, it's quite straightforward. So let's just try and create this one. So it should work. And you can see there are 121,000 shots. So we can just see what it looks like. So let's say select everything from xg temp 1. So this is it. So we just given one value for the shot distance, the shot angle, the string state, the score state, the last event, and the shot types. So these are our variables, and how much this particular shot is worth in terms of shot distance, in terms of shot angle, in terms of string state, and so on. So the next thing we need to do is how do we calculate the xg value based on this? Well, because it's a logistic regression model, we just need to use this formula right here. So it's 1 over 1 in the exp. I don't know what it's called in English, but yeah, and then the minus value of all of these summed up, and that will give us the xg value. So that's just how a logistic regression model works. So you can just maybe read up on it, I suppose, if this is not about the math so much as it's about how you can build the XG model. So when you do a logistic regression model, you just have to put it in this formula right here with these as your variables. So these are how much, so these are just those right here. And when we do that, we do get the XG value. So let's just try and run it. Hopefully it makes sense when you do it yourself. And again, let's just try and select from it. Select everything from xg temp 2. So that's it. So now we have a table with just the event ID and the XG value based on the model that we just built. And you can see the values goes from very, very small percentage of going in and all the way up to a 41.7% chance of going in. And remember, these doesn't include empty net situations. So a shot with a 42% chance is a very big chance. But I suppose if you had better data and more variables, you could have XG values that were higher than 50%, maybe even up to upwards of 70–80% if the model is good. But in this model, there is no XG values higher than 42%. Anyway, this is our XG model. So the last thing we need to do is we need to just combine this with our play-by-play adjusted table. So we'll just, so let's just put it in here, play-by-play adjusted. So in one of the first MySQL videos I did, we created this play-by-play table. So it's just a play-by-play table of all events in this season. And then you have the event ID, so we can just couple the play-by-play adjusted with the XGTemp2 that we just created, which has the event IDs and the XG values. So that's what I did in the very last part here. So I created a play-by-play data table where I cleaned it up just a little bit and added the XG value in the end. So we can just try and open the play-by-play data just to illustrate what it looks like. So this is all of the play-by-play data, and then in the end you have the XG values, and you can say it's all blank here, but that's because these are not shots. So down here you have a shot with the shot distance, shot angle, and the XG value. So this particular shot has a 2.5% chance of going in, according to the XG model. So that's what it looks like. So now we created our XG model in Python. We saved all the coefficients so that we could recreate it in MySQL. So we only had to do the modeling once in Python, and then we have all the data so that we can recreate the XG values based on the variables. So I hope this makes sense. It's a little bit complicated, it's a little bit complex, and Python is definitely not my strength. But it does work, and using Scikit-learn, the library, is super easy. So it's very, very easy to build a logistic regression model, even with much larger data sets and with many more variables. You can still build it quite easily. So we got what we wanted to do. So I hope you could follow along, and I hope I will save all of the scripts. I will save this in the description. I will save all of the code here in the Jupyter notebook. I'll save that under the description as well, and I'll leave the links for this video where he installs the Jupyter notebook and the Anaconda. And yeah, I think that's it. So that will be all for now. See you next time.